Let's add the ability to dynamically add new users. We can do so with the help of a mutation. So we'll add a class mutation that subclasses from graphene.objectType. Then we'll provide our root mutation type to our schema, just like we did for our root query type. We'll name the mutation that we'll use to create users create user. We're registering this new mutation that we'll make with our root mutation type, and it's going to be set to create user.field. Create user will be a class that will do the work of creating our users, and for every new mutation that we make on the root mutation class, it's always going to have this pattern of a class.field. Now let's make the class create user, and this is going to subclass from graphene.mutation instead of object type. We saw in the previous video how we could supply arguments to our queries. Supplying arguments to mutations involves a slightly different pattern. We need to include an inner class to our create user class called arguments to pass in our arguments. We're going to supply only one argument to create user, and that will be the username. So our username argument once again will be of type string. The resolver function for create user will have the name mutate. It's not going to be named based on the name of the mutation. It'll always be mutate for every mutation, and it will accept, like with queries, self, info, and then any arguments. So we'll supply our username argument, and here we'll create a new user where the username is going to come from our username argument, and our two other values created at an ID we don't want to be passed in. We just want them to be created automatically. So ID will be set to some string and created at datetime.now. We'll store our created user in a user variable, and naturally we want create user to return our entire user. So up at the top above arguments, we can specify our one subfield user, which is going to take the shape of our user model. So we can set that to graphene.field and pass in our user, just like we did for graphene.list with our users query. And then finally, at the end of our mutate function, our resolver function, we can return create user and then supply our user subfield. That, of course, being set to our created user. Now let's test this out. We'll execute our create user mutation. First of all, using the keyword mutation. Then we'll supply the name create user, pass in a username, make sure that this username is within double quotes, and on create user we're going to have a user subclass, which is then going to contain all of our subfields from the user class, ID, username, and created at. So let's save schema.py and try executing this, and we get our created user. One thing that we can change about this, however, is instead of for these automatically created values, ID and created at, instead of having to supply them here within our resolver, we can provide them as default values within our user class. So if we want our created at value to always be the current date, we can say default value is set to datetime.now, and if we want a unique string, we can import UUID to create a unique ID instead of having to generate one ourselves every time, and supply a default value set to uuid.uuid4 and convert this value to a string. So with these default values, we can remove from our mutate function within create user ID and created at, when we create a new user, save schema.py, and if we run it, we automatically have supplied to our created user a unique ID as well as the current date.